Hi, I'm Thomas. Welcome to the Lightboard session about application optimization. Application optimization is part of the SD-WAN offering of Open Systems. Let's have a look where it fits into the SD-WAN stack. At the bottom, the plate, we have the lines, which connect all your locations. On top of that, we have path selection, the muffin. With path selection, you can choose which of your lines should be used for which application, and we can ensure that the best available line is used for your business critical applications. On top of that, we have the icing. The icing is bandwidth control. With bandwidth control, we make sure that even if your lines get congested because the applications use more than the available bandwidth, with bandwidth control we make sure that your business critical applications are protected and get the required bandwidth. On top of that, we have the cherry, application optimization. With application optimization, we can reduce the bandwidth requirements for your applications, and we can overcome the effects of high latency or packet loss and optimize the performance of your applications. What is application optimization? The application optimization service is designed to improve the quality and performance of your traffic within your network, connecting different locations. The methods we have to optimize your traffic are compression, caching or block level deduplication, TCP optimization, and protocol specific optimization. The goal of all these is to either reduce the bandwidth consumption of your applications or to improve the performance in case your lines have high latency or suffer from packet loss. Application optimization will reduce the bandwidth that is needed in your network by applying compression. So whenever a file is fetched from a server, we will apply lossless compression algorithms to reduce the size of the file, so that the amount of data that has to be transferred across your network is much lower than the original file. On the remote edge device, we will undo the compression and deliver the original file to the client. By using caching or block level deduplication, application optimization can reduce the bandwidth that is required between your locations. So when a client downloads a file from a server, we will cache the data that has been transferred between the two edge devices. So when a second client requests the same file, instead of transferring the whole file again, we already have it in the cache. So instead of transferring the whole file, we can transfer a block reference to the data in the cache. On the client side, that cache reference will be used to do a lookup in the cache to find the file that was requested, and that file can then be sent to the client. It doesn't matter how the clients do access the file. So it can be that initially the file was transferred in an email, and the second file request was via HTTP or FTP or Samba. Because the cache doesn't cache the file itself, but it caches the bytes. So whenever we see the same byte sequence, we can replace it by a reference to the address where that byte sequence is stored. That also ensures that, let's say, the file was updated on the server. So part of the file remains the same, but part has been changed. In that case, we would still transfer a block reference to the data that was not changed, and in addition, transfer the part that has been changed, so that the client will always receive an up-to-date version of the file. And of course, that change would then also be stored in the cache. Like this, we can reduce the amount of data that has to be transferred between the edge devices drastically. Application optimization is based on TCP optimization. So whenever a client establishes a connection to a server, we will intercept that session and establish a new session between the open system's edge devices. The edge device will then establish a session to the server. As we are in control of the TCP connection between the two edge devices, we can ensure that we use a TCP algorithm which is designed to provide optimal performance, even in cases where the line suffers from either packet loss or there is a high latency. By doing optimization on the TCP level, we can also ensure that we can provide optimization for your applications that are encrypted and where the other optimization options wouldn't be available. For applications that are based on HTTP or CIFS, it is possible to apply protocol-specific optimization. HTTP requests usually come with a large header. Across different requests, these headers tend to be very similar. So what we do is we replace the big header by a smaller representation. The CIFS protocol is a very chatty protocol. We accelerate that application by reducing the back and forth by using read ahead and write behind. In this way, we can optimize the traffic by either reducing the required bandwidth for HTTP traffic or reducing the effects of latency for the CIFS protocol.